live. Hello, good morning. Welcome to the reading group. And I'm gonna stall for a little bit because I want to make sure that the both videos are actually streaming, because it's something I have been struggling with recently. Sending data and online. Those are words that I like to see. Fantastic. All right, we're good to go. Wait, are we? Yes, we are. Fantastic. Hi, good morning. It's been a busy one for me, and I realize that it is 9 o'clock. 9 o'clock a.m. my time, which is not super late is the word that I was looking for. We are going to be continuing to work on this paper that we've been reading. So we started not last week, but 2 weeks ago, and Vincent joined me, and he's got a lot on his plate right now. So this week it's just going to be me. I hope you can contain your disappointment. Oh, I don't need this anymore. And the paper is Beyond Accuracy, Behavioral Testing of NLP Models with Checklist. It is from ACL 2020. So ACL is maybe... so there's this organization, the Association for Computational Linguistics, that runs all the biggest and best, one sec, I can be a bit louder, runs all the biggest and best NLP conferences, basically. It's the most prestigious venue, and ACL is the flagship conference, and this paper won Best Paper. So I would say a very paper that the community has sort of earmarked as being very high quality. And it was written by Marco Ribeiro, Tongshuang Wu, Carlos Guestrin, who I'm pretty sure is at Apple. He might have a dual affiliation. It's not listed here. And then Singh. So for Microsoft Research, University of Washington, University of California, Irvine. And the sort of gist of it that we talked about last week, 2 weeks ago, is that it's a grid of functionality that you can use to assess a range of NLP models. So it's a number of different things that you want to test, a number of different types of ways of testing them, and then those things combine and make a grid. And then you pick out the parts of the grid that are most relevant for you and your work, and then you develop tests that fit in that grid. So it's a very general framework that allows you to compare models that are very different on how well they handle different types of linguistic input, which sounds very useful. And I believe I got to like section 3.4, but let's quickly look at an example just to talk about what this can look like. So here we have this is a sentiment analysis model. So it's a model that looks at some tests and says the person who was writing this enjoyed something, or they didn't enjoy it, or they didn't have like strong feelings one way or the other. And then there are 3 things that it's looking at. So one is vocabulary, the specific words. One is NER, named entity recognition, and another is negation. Minimum functionality test is, does it do the thing that you want it to do, if I remember correctly? Simple test case is designed to target a specific behavior, and they just expect that if you negate a positive verb, you should get negative sentiment. The invariance, if you change something that should not change the output of the model, then you shouldn't see a change in the output of the model. So in this example, if you change the entity in a text, so if I said I love, I don't know, I'm trying to come up with a name of a movie and I can't. I love The Princess Bride. That should get the same sentiment as I love, gotta come up with a second movie, Groundhog Day. So changing the entity there should not change the overall sentiment, and that's what this invariance test is. And then directional, so this is for a system where things are on a scale and you want to change the input in such a way that you expect a change on that scale. So for sentiment analysis, it's usually positive, neutral, negative. So here adding a statement that's very neutral, very negative should take, a neutral sentiment and then bring it down to negative. Or if it's already negative, keep it negative. So those are the specific things that they're changing. This is the way that they are testing those changes. And then this is, I believe this is failure rate, actually. So some of these failure rates are pretty high, particularly this one where the positive verb recommend and love was negated, can't say and didn't. And that did not... And the expected labels here were negative and the actual labels were positive and neutral, respectively. So that's the general idea. How am I today? I'm okay. A little tired, but mostly okay. So we talked about capabilities. So these are different things that a model can do. And we talked about test types as well. So an MFT, let's just start reading at the test type section, I think. I believe we ended up with section 2.3. So test types. Hey, Faiza. Or Faiza, I'm sorry if I'm saying that wrong. We prompt users to evaluate each capability with 3 different test types when possible: minimum functionality tests, invariance, and directional expectation tests, the columns in the matrix. A minimum functionality test, MFT, inspired by unit tests in software engineering, is a collection of simple examples and labels to check a behavior within a capability. MFTs are similar to creating small and focused testing data sets and are particularly useful for detecting when models use shortcuts to handle complex inputs without actually mastering the capability. So this example where you negate the positive verb, and that should create a negative sentiment. If the model is instead looking for just the precedence of a positive verb, then it will fail this test. The vocabulary plus part of speech examples in the previous section were all MFTs, minimum functional tests. And those were from the section above that we read last time. We also introduced 2 additional test types inspired by software metamorphic tests. An invariance test is when we apply label-preserving perturbations to inputs and expect the model prediction to remain the same. So you change something about the data, but that change should not change the model output. Different perturbation functionalities are needed for different capabilities, e.g. changing location names for the named entity recognition capability for sentiment, or introducing typos to test the robustness capability. A directional expectation test, so that's the 3rd type, is similar, except that the label is expected to change in a certain way. For example, we accept that sentiment will not become more positive if we add "you are lame," which is a little bit ableist, but is definitely not a positive thing to say, to the end of tweets directed at an airline. This expectation may also be a target label, e.g. replacing locations in only one of the questions in QQP, such as how many people are there in England, what is the population of Turkey? So changing England to Turkey. And I believe this test, QQP, is detecting whether or not 2 questions are looking for the same piece of information. Let's see where they define this. Duplicate question detection. Yes. So how many people are there in England and what is the population of England are the same question. How many people are there in England and what is the population of Turkey are different questions that would give you different answers. This ensures that the questions are not duplicates. INVs, INVs, and DIRs, so invariance tests and directional expectation tests, allow us to test models on unlabeled data. They test behaviors that do not rely on ground truth labels, but rather on relationships between predictions after perturbations are applied, invariance, monotonicity, etc. And this is a good thing because labeling data takes time and money. And when you are writing tests, if you can spend less time and less money writing tests, but still have equally reliable results, that's ideal. Generating test cases at scale. So I will say this is a place where I would definitely move with caution, and we'll see what they say about it. But certainly for conversations, the test data that I would recommend that you use is a conversation that a real person actually had with your assistant that was successful. Users can create test cases from scratch or by perturbing an existing data set. Starting from scratch makes it easier to create a small number of high-quality test cases for specific phenomena that may be underrepresented or confounded in the original data set. So looking for something in particular that you didn't see a lot of in your original data set, or that always occurred with something else that you want to be able to separate. Writing from scratch, however, requires significant creativity and effort, often leading to tests that have low coverage or are expensive and time-consuming to produce. Perturbation functions are harder to craft, but generate many test cases at once. So perturbation just means a change. To support both cases, we provide a variety of abstractions that scale up test creation from scratch and make perturbations easier to craft. So templates. And I will say templates in NLP have a long and illustrious history. A lot of the sort of early work in like the block world stuff, which I think was in the 60s or 70s. When was block world? Let me actually check that out really quick. Block world. NLP. All of these were about games that are not what I'm looking for. DARPA? I feel like it was a bake-off thing. Anyway, Block World was, and that may not actually be what the name was, but what I refer to it as in my head was an early conversational AI system where you had a like a virtual environment that had different shapes in it, and you could manipulate those shapes and move them and stack them on top of each other using text commands. And it was probably, it definitely postdates ELIZA. I feel pretty confident saying. ELIZA was a very early conversational system that just sort of repeated your statement back to you as a question. And people got like hyped about it. They were like, the future is here. Conversation is the interface of the future. And it turned out it did not generalize more to more complex situations or the real world. And then I think that was the first big AI NLP winter. Anyway, if anyone has like the correct citation, feel free to pop it in the chat. And that system used templates. That was the whole thing that I was going back to say. And a lot of the early like text-based chat games used templates. So very, very venerable thing. They're not proposing this now. Test cases and perturbations can often be generalized into a template to test the model on a more diverse set of inputs. In figure 1, we generalized I didn't love the food with the template I negation positive verb the thing, where negation was something in the set didn't, can't say I, etc. Positive verb was something in the set of love, like, etc. And thing was in the set food, flight, service, etc. So they had a list of words for each of these slots, and I'm guessing, generated all test set cases with a Cartesian product. So they just used all the combinations. A more diverse set of inputs is particularly helpful when a small set of test cases could miss a failure, e.g. if a model works for some forms of negation, but not others. So your model always works for didn't, but never works for can't say I. That's something that you would want to know. And I will say that templates like this work best with languages that don't have a lot of complex morphology and agreement between words. If you have things like, you know, a very rich case system, or in this case, I think for most languages with gender that I'm particularly familiar with, it shouldn't be a big issue, but for things that have more agreement between words, you need to be a little bit craftsier. Expanding templates. While templates help scale up test case generation, they still rely on the user's creativity to create fill-in values for each placeholder, e.g. positive verbs for pause verb. We provide users with an abstraction where they mask part of a template and get a masked language. Get masked language model suggestions for fill-ins, and they used Roberta, e.g. I really mask the flight, yields enjoyed, liked, loved, regret, etc., which the user can filter into positive, negative, and neutral fill-in lists and later reuse across multiple tests. Oh, that's really interesting. There's a blog post that Vincent wrote a while ago about GPT-3 where he did something similar. We used GPT-3 to generate cases and then like sorted them by hand, basically. So if you're struggling to come up with words and also you're working specifically in English, this might be a good choice for you. I know that there's a multilingual flavor of BERT, and GPT-3 is not trained solely on English data, so it might possibly work for this, but that's a beeping sound. I don't know if you can hear that. This approach is going to rely on you having access to a masked language model that works for your specific language and situation. And then you filter them. Figure 2. So let's check out figure 2. So this looks like an interface, but I think it's just like a... maybe this is an interface? Let's see. Figure 2. Templating with masked language models. I really blank the flight yields verbs that the user can interactively filter into positive, negative, and neutral fill-in lists. So this section has like I, ... we, really, the masks. So these were generated by the system, or by the masked language model, Roberta. Enjoyed, liked, love, regret. And then it looks like this person has selected the positive verbs. And for here, we've got more options for this determiner. It could be the, this, that, my as a determiner, and then flight, which is, okay, so they're just doing one thing at a time, and then presumably later they try this mask trick with flight to generate other things that the person could be responding to. Sometimes Roberta's suggestions can be used without filtering, e.g. this is a good blank, yields multiple nouns that don't need filtering. I can think of some things I wouldn't want to have filling that spot in my test data. They can also be used in perturbations, e.g. replacing neutral words like that or the for other words in context. I think they mean neutral in terms of sentiment, and I don't know that I agree the determiner choice is neutral in terms of sentiment always. Vocabulary part of speech. Inversion test, I believe that is. Example in table 1. This says, I'm writing on my Rasa project documentation too. Oh, fun. Galetta says, hey Rachel, hi, I have a question. When it says perturbing, how is this done? So I think by perturbing here, they just mean changing a word. Using, say, this masking example. It could also be something like replacing a word with a typo in it, which I believe that they'll talk about that a little bit later on, maybe. They can also be used in perturbations, e.g. replacing neutral. Okay, so this is that exact thing where they're replacing something with something else. Roberta suggestions can be combined with WordNet categories, synonyms, antonyms, etc., e.g., such that only context-appropriate synonyms get selected in a perturbation. So WordNet is a big data set that has, it's in English. Are all of the things in this paper in English? Yeah, almost certainly. That has sort of relationships between words and also different concepts. So synonyms are words that mean the same thing as other things, and that's like a, if WordNet is a graph structure, synonyms would have an edge that's like these two words mean the same thing. Antonyms, they'd have an edge that mean these two words mean opposite things, and you can use that that information to query the data set. Such that only context-appropriate synonyms get selected in a perturbation. We also provide additional common fill-ins for general-purpose categories, such as named entities, common male and female first-last names, cities, countries, etc. And I believe when we looked at this, Vincent and I looked at this 2 weeks ago, these names were very like white European names. So again, probably not going to work for every situation. And protected group adjectives, nationalities, religions, gender, and sexuality, etc. Did we miss table 1? Have we just not talked about it yet? Table 1, okay. So we have a couple sessions to go before we get to table 1, which shows up here. Open source. We released an implementation of checklist at github.com/MarcoTCR, the first author's personal GitHub, I'm assuming, /checklist. In addition to templating features and mask language model suggestions, it contains various visualizations, abstractions for writing test expectations, e.g. monotonicity, and perturbations, sharing, saving tests, and test suites such that tests can be reused with different models and by different teams, and general purpose perturbations such as character swaps, simulating typos. So instead of TEH, THE, you switch the E and the H and have THE, which is the incorrect spelling of the. Although I don't think it is anymore, but at some point in the past, that particular incorrect spelling of the had some social meaning. Contractions, so I cannot to I can't, name and location changes, etc. So Vince and I looked through this repository a little bit last week and 2 weeks ago, and like I mentioned, it's very English focused. It's very sort of like North American, European focused. So if you're working in another language or with another population, you'd probably have to do some zhuzhing. All right, testing state-of-the-art models with checklist. So state-of-the-art models are usually there is one specific metric or a metric that's a combination of metrics, like the GLUE benchmark, which is a bunch of different test sets, and then you look at your overall performance on the whole, all of the different test tasks. And the state-of-the-art model is whatever model currently has the highest score. And this does sometimes mean that these models are very specialized for the particular tasks that they're trained on, but may not always generalize super well. So in the speech community, there's a really widely used data set of telephony speech, so people talking on the telephone, that's used as sort of a benchmark for a lot of ASR systems, but it's older. It was recorded on the telephone. All the people in it are, I want to say it was recorded at Bell Labs. Switchboard. Switchboard is the data set that I'm thinking of. Sorry, that was me trying to get switchboard corpus. And if you listen to some of the speech, you're like, oh, this sounds a little bit old-timey at this point. So if you're really focused on your performance on one particular data set, you may not, it may not expand as well, or it may have other limitations like being incredibly big or incredibly expensive. And what they're looking at here in particular is that they are looking at how these different models work when you change the data in ways that you expect will affect the outcome in particular ways. And I'm just 1993 for release 2 of Switchboard. No, 1990 to 1991. I'm just gonna pop this up. So the Linguistic Data Consortium is a place where you can go to get extremely expensive corpora. And yeah, it was collected by Texas Instruments, not Bell Labs, whoopsie, in 1990 to 1991 under DARPA sponsorship. So kind of, you know, a little bit venerable at this point. So they checklist the following commercial sentiment analysis models via their paid APIs. Microsoft Text Analytics, little Windows icon, Google Cloud's Natural Language, little Google icon, and Amazon's Comprehend, little Amazon icon. We also checklist BERT Base, BERT icon, and Roberta Base, ROB, Liu et al. 2019, fine-tuned on SST2 from 11/2019, so November 2019, but obtained similar results from April 2020. And then, oh, sorry, so this is when they ran all of these tests, and then they checked them 5 months later after they'd submitted the paper and it had been accepted, I'm assuming. Predictions with a probability of positive sentiment in the 1-3-2-3 range are considered neutral. Sorry, 1/3 to 2/3 range are considered neutral. I think this is just a sentiment analysis data set. I haven't worked in sentiment analysis a whole bunch, so I'm not super familiar with the data sets there. Blah, blah, blah. So fine-tuned on that. And then the this data set, which is to find questions that are duplicates of each other. All right. And then the accuracy. Okay, so this fine-tuning is specifically of Roberta. It's been fine-tuned on, okay, but both of these models need to be fine-tuned. So, okay. I'm picking up what they're putting down. This sentence structure is just confusing. So BERT and Roberta are both models that are designed to be pre-trained models that you then fine-tune for a specific task. And they are saying that they fine-tuned it for 2 tasks. One with this sentiment analysis task. BERT base had 92.7% accuracy. Roberta had 94.8% accuracy. And then this duplicate question detection task. And BERT base had 91.1% accuracy, and Roberta had 91.3% accuracy. Okay, makes sense. And as I remember, I think Roberta is a little bit more lightweight than BERT. Like some of the, I don't know if it's pruning or the specific things that they did to the model to make it smaller, but I believe that it is smaller and faster. For MC, we use a pre-trained BERT large fine-tuned on Squad, which I believe is a Stanford question answering dataset, Wolf et al. 2019, achieving 93.2 F1. Which it goes from 0 to 100. All the tests presented here are part of the open source release and can be easily replicated and applied on new models. And did we talk about table 1 in there? I don't think we did. No. Okay. Sentiment analysis. Since social media is listed as a use case for these commercial models, we test on that domain and use a dataset of unlabeled airline tweets for invariance and directionality perturbation tests. So like changing the name of the airline should not change the output. And if you add a sentence like, I hated it to the end of the tweet, the sentiment should not get better. It might remain where it is or it might get worse. And both of those would be fine. Are we still alive? Yes, we are. Okay, great. I had a moment where I was worried that the stream had failed. I'd been having some difficulties. We create tests for a broad range of capabilities and present subset with high failure rates in table 1. So they tried a lot of things and they're just sharing the places where these models don't do well, which I think is fair because these are commercial models, so they paid for this. And also they are, well, they might have gotten like credit for Microsoft because one of the authors works there. But they're doing things that the commercial models say that they can do. So I think it's very reasonable to be like, and here's where it didn't work, because you would expect that it would work and would be able to, you know, meet all these measures of quality that they proposed. The vocabulary plus part of speech minimal functionality tests are sanity checks, where we expect models to appropriately handle common neutral or sentiment-laden words. So neutral would be, I don't know, I'm trying to think of a neutral word, like apple. Apple shouldn't have a very strong or negative positive sentiment. Maybe slightly positive because of things like apple of my eye. or sentiment-laden words like hate for negative sentiment or love for positive sentiment. Bert and Roberta do poorly on neutral predictions. They were trained on binary labels only. So they can't give a neutral prediction. They can only give a positive or negative prediction. So they didn't guess neutral ever, which makes sense. Surprisingly, Google and Amazon fail 7.6% and 4.8% on sentences that are clearly neutral, while Google also failing 15% on non-neutral sanity checks, e.g., I like this seat, which should be given positive sentiment and was not. In the directionality tests, the sentiment scores predicted by Windows and Google frequently, 12.6% for Windows, Microsoft, 12.4% for Google, frequently go down considerably when clearly positive phrases, e.g., you are extraordinary, are added, or up, Google 3.34% for negative phrases, e.g., you are lame. Again, ableist, but a clearly negative thing to say. Hello, Mirabik. Welcome to the stream. So, what they're saying is that the models that were not trained to give neutral predictions did not give neutral predictions. That's not surprising. It would be surprising if they did. In fact, that would be worrying that the model produced a class it wasn't trained on. Both Google and Amazon failed on, had failure rates on neutral sentiments. Google had failure rates on had a high failure rate for things that had positive sentiment. The Microsoft and Google models both had sentiment that went down when positive phrases were added, and the Google model had sentiment increase when negative phrases were added. And I think all of these are in table 1. And I'm going to finish this section before we go up and look at it, I think, just so we can use that table to verify what we're getting from the text. All models are sensitive to the addition of random, not adversarial, shortened URLs or Twitter handles, e.g. 24% of Amazon prediction change, and to name changes such as location. Google 20%, Amazon 14%, or person names, Google 15%, Amazon 9%. So these are things that you would expect would not change the sentiment. So just adding a URL should, URLs don't have sentiment associated with them. I guess some of them might, but these are just random URLs, so it wouldn't be easy to sort of extract it. And then changing the name or location changed the model output, which is not, names and locations should not inherently have sentiment for something like reporting how your flight was. None of the models do well in tests for the temporal, negation, and SRL capabilities. So temporal, I'm guessing changing tense. So was, is, will be. Negation, adding negation probably to the verb. And SRL, I don't remember that one. SRL. Order is irrelevant for comparisons. Order is irrelevant. Let me see, was this one? Okay, so subject, object, or active, passive distinctions. Okay, so I'm guessing that this is like, oh, what's the word I'm looking for? Grammatical changes that should not change the content of the sentence, especially. Failures on negations such as the food is not poor are particularly notable for Google 50% and Amazon 30%. The failure rate is near 100% for all commercial models when the negation comes at the end of the sentence. I thought the plane would be awful, but it wasn't. So all of these models are giving this a positive, negative sentiment, excuse me. or with neutral content between the negation and sentiment-laden words. So sometimes they can handle, I didn't love the plane, but they can't handle, like, I didn't really love the plane, that sort of thing. Commercial models do not fail around simple fairness sanity checks, such as I am a Black woman. Template, I am a protected noun. So this would be a word from a protected category, and this would be a noun describing a person. Always predicting them as neutral, which is great. If you've listened to the podcast that we just put out, the discussion that Zariq and Alina and I had, we talked about the jigsaw thing a little bit, where things with neutral sentiment like I'm a Black woman would be given negative sentiment evaluations, whereas things like I'm a white man would be given positive sentiment evaluation. So it looks like these systems don't have that problem, which is fantastic. And I'm sure due to explicit work on this by the respective engineering teams. Always predicting them as neutral. Similar to software engineering, absence of test failure does not imply that these models are fair, just that these are not unfair enough to fail simple tests. On the other hand, BERT always predicted negative when protected is Black, atheist, gay, and lesbian, while predicting positive for Asian, straight, etc. So this is a big problem, particularly with mass language models that are trained on internet data, because internet data includes hate speech, and if your model is trained on hate speech, it's going to pick up on those correlations. With the expectation, I'm not saying everything on the internet is hate speech. I'm just saying that there is hate speech in the training data for BERT and definitely for the GPT star models. With the exception of tests that depend on predicting neutral, BERT and Roberta did better on all commercial models on almost every other test. This is a surprising result, since the commercial models list social media as a use case and are under regular testing and improvement with customer feedback, while BERT and Roberta are research models trained on the SST2 dataset, movie reviews. Finally, BERT and Roberta fail simple negation MFTs, minimum functionality tests, even though they are fairly accurate, on the subset of SST2 validation data that contains negation in some form. So these mass language models do okay, which does make sense because these are transformer models, so they should be able to pick up on things that are... It sounds like the other models had a failure state when the negation and the verb were too far from each other, and that the transformer-based models are able to handle that, and that would make perfect sense to me if the other models were recurrent neural networks. Which I don't imagine the source code for the commercially available Microsoft sentiment analysis model is available, but I wouldn't be shocked if they were using recurrent neural networks. And it looks like the transformer-based language models are able to handle that a little bit better, but they do have the fairness problems, those particular fairness problems that was outlined above. And interestingly, they can handle negation fairly well, which again makes sense even when it's distinct because of the attention. Although I guess it makes sense that that's the case, but I wouldn't a priori have guessed that that would be the case, because I believe there is other work on the cow et al. Paper from 2018 on what do masked language models learn, I believe is the title, or something like that, which found that for negation tasks, BERT in particular, I believe it was BERT, is just looking for the presence of the word no, basically, which is not... yeah. No, I don't have anything else to say about that. I'm just thinking. But by isolating behaviors like these, our tests are able to evaluate capabilities more precisely, whereas performance on the original dataset can be misleading. Yeah, Robbie says, sentiment analysis is my favorite topic. Oh, fun. I will say it's not mine. I just think there's other more interesting NLP tasks. At McCurry, I'm getting an error while deploying Rasa X. Post about it on the forums, and yeah, that's probably the best place to get help if you have a specific error. We also have some deployment videos for Rasa X on the channel that might be helpful if it's an installation thing. All right, let's look at this table, which is very far above. There we go. Table 1. All right. So, looking at the failure rate, I'm just gonna pick things up. So neutral, Roberta and Bert both did awful because they don't have a neutral class, so that makes sense. In fact, I'm surprised that this is not 100. Sort sentiments with some adjectives. Most models did pretty good. Replacing neutral words with other neutral words. Most models did okay. Adding positive phrases fails if the sentiment goes down. Both Microsoft and Google struggled with that a little bit. And then adding negative phrases fails if sentiment goes up. It looks like Google really struggled with that. Adding something like "I abhor you," which, weird thing to say, should take the sentiment down, and for the Google model, the sentiment would actually go up when you added that phrase. This one, it looks like the Amazon model does not do well when you add random URLs, which, looks like that's a link. Should not actually, and handle should not actually change the sentiment of the tweet. The Google model didn't do well when you change location, so changing the flight of the Cuba to flight, the location of the flight from Cuba to Canada or San Jose to Denver shouldn't change the sentiment, but it looked like it did for the Google model pretty often. Sentiment change over time. Present should prevail. I used to hate this airline, but now I like it. Oh, I see. So if you're talking about past sentiment and now your current sentiment, the current sentiment that you have should be the one that has the most important information. And it looks like Bert and Roberta handle that fairly well, and the other commercial models do not. Robbie says, sentiment analysis is often. Why don't you like it? My interest in different NLP, tasks is really down to the amount of impact that it can have in the world. And I think that sentiment analysis is it's a really big simplification of how people interact and what they may be thinking or feeling. And I don't think that it has a lot of applications that are really really improve people's lives for the better, if that makes sense. One thing that makes me excited about conversational AI and conversational interfaces is that it really has the potential to genuinely improve people's lives by making things more accessible. Like, I've known many people in my life who do not know how to use a mouse, right? That have no computer literacy. And for them, being able to talk to a system using, their voice or signing, or a language system that they already know how to use, is a big increase in their quality of life. Like, you don't have to wait for business hours to call a company. I don't think sentiment analysis has that same degree of potential upside. So that's just me. That's just my my stance on the matter. Yeah, Robbie says, I don't like ML. There's so many algorithms. I mean, there's a lot of things that it's useful for, and different algorithms are useful for different things. So. Nomad Clear Sky says, what's a good place to start with text analysis? So if you're looking for analysis to sort of like communicate information about a text, are for the Tidy textbook. Let me see if I can find the title really quick. Text mining with R is the text, and it's actually available for free online. I'll paste it on in Twitch real quick. Is really good if what you're interested in doing is communicating information about a text. If you're more interested in doing NLP engineering, speech and language processing by Drafsky and Martin is sort of the textbook people use for intro NLP. And I like textbooks because they really make sure that you don't have any depending on the textbook. Those are textbooks that I enjoy. You don't have any big gaps in your knowledge, which can often happen if you're just sort of like working on projects and don't have structure for things to learn about. So, all right. Bobby says, bots are only for customer service? No, not necessarily. I mean, anything that you do with a mouse and a keyboard, you could do with a conversational assistant. Like, there are lots of chatbots used for customer service, but they have many, many more applications than that. You know, public health. There's a Adobe... I think it's a Photoshop bot. There was a talk at it at Rasa Days. It's on the YouTube channel where they created a conversational assistant where you're like, hey, I want to make this image 20% bigger, and you just say that in words. You don't have to remember all the very complex Photoshop commands, and it just does it. I think that's a really nice way to create an interface that's very intuitive and usable. So I just, like, sentiment analysis is a very, 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 very narrow question that really reduces the complexity of the text itself in a way that is sometimes useful, but not always. Nomad says, are these mostly black box algorithms? Yes. So the Windows, Google, and Amazon models, I don't believe. So these are the commercial models that you would pay them to use their API. They may have talked about some of the internals in white papers, but I don't think there's a lot of information about them. BERT is actually it is a Google model, and it was a research model. So BERT is open source, and then Roberta is a smaller version of BERT that is also open source. And I don't remember what institution those authors were from. It might also be a Google model. Don't quote me on that. So black box, black box, black box. I mean, as much as transformer models are not black boxes, you can see the code for BERT and Roberta. All right. Other failure modes. So this is really, really high, these ones. Negation of negative at the end should be positive or neutral. So I thought the plane would be awful, but it wasn't. I thought I would dislike the plane, but I didn't. It looks like every model but Roberta really fails on this particular task. And both of the models don't do well. BERT and Roberta don't do well on this neutral task because they just don't have a neutral class, so that's kind of expected. And then this one, negated positive with neutral content in the middle. It looks like Roberta did better of all of these models, but this looks to be fairly difficult. I wouldn't say, given it's a Tuesday, that this pilot was great. So there is neutral information in the middle that separates the negated verb from its beans. Ooh, is it a complement? The clause that's attached to the verb. It's been a minute since I took syntax, y'all. But they're saying that when you add additional neutral information in the middle, it shouldn't change the output. And then for this one, do I think the pilot was fantastic? No. Do I think the company is bad? No. This should have negative or neutral sentiment, and these were all given, I'm guessing this was given positive sentiment, and this was given negative or neutral sentiment. So the fact that this negation should apply to this entire statement, certainly the commercial models were fooled by, and these the transformer-based models were also really struggled with that. So. Ujjal says, any textbooks for learning machine learning? A lot of them, yes. If you're, I don't know if they have a textbook, but the Fast AI courses are pretty good if you're interested in just sort of modern neural deep learning engineering processes. Yeah, I have fewer recommendations for general machine learning than specifically NLP, because my degree is in linguistics and NLP and not pure machine learning. Yeah. Robbie says the purpose of any conversation is to understand the other person's behavior. I don't know that I would agree with that. I have conversations in many contexts for many reasons, and understanding what the other person is doing is not always my primary goal. Feza, can you make a tutorial on how to use Duckling? Not in the near future, but I will add it to the ideas list. Duckling's been around for a while, though, and I bet that you can, if you dig around a little bit, find some really good tutorials online. All right, so this was the sort of, these were the tests on the sentiment analysis, and I think the next section are going to be the tests on the duplicate question detection. I will be almost certain. Okay, so they're saying that these transformer-based models did pretty well, especially for things where detecting neutral wasn't part of the success condition. Okay, core question pair. Well, Bert and Roberta surpassed human accuracy on QQP in benchmarks. The subset of tests in Table 2 indicate that these models are far from solving the question paraphrase problem, and are likely relying on shortcuts for their high accuracy. Both models lack what seem to be crucial skills for the task, ignoring important modifiers on the vocabulary test, and lacking basic taxonomy understanding, e.g. synonyms and antonyms of common words. Further, neither is robust to typos or simple paraphrases. The failure rates for the NER tests indicate that these models are relying on shortcuts, such as anchoring on named entities too strongly, or instead of understanding named entities and their impact on whether questions are duplicates. One sec. Thank you. Sorry about that. So this section is saying that these transformer-based models are not actually doing the test that task you in the way that a human would do it. They're using sort of statistical shortcuts in the text data. Surprisingly, the models often fail to make simple temporal distinctions, e.g. is does not equal used to be, and before does not equal after. And to distinguish between simple co-references, he does not equal she. So I would say it's pretty rare for he and she to be used to refer to the same person. In SRL tests, neither model is able to handle agent-predicate changes or active-passive swaps. An active-passive swap would be like, I wrote the paper, would be the active voice. The paper was written by me, would be the passive voice, because the agent of the sentence, the person who's doing the thing, is now the object. Pretty sure. I enjoy this paper because it's really dusting off some of the oldie linguistic skills. Finally, Bert and Roberta change predictions 4.4 and 2.2% of the time when the question order is flipped. That shouldn't happen. The question order should not matter. But it makes sense because the way that you pass things into Bert and Roberta is you have, for your training data, the first token is, these are the same or these are different, and then the first string, and then a separator, and then the second string, and then you train on that for a bunch, and then to get the answer out, you do, first string, middle, separator, second string, and then you look at what the first token, whether it's the same or different, is predicted to be. So order does matter there, even though it doesn't for the task. Failing basic task requirements, e.g. if question 1 is a duplicate of question 2 is a duplicate of question 1, so it doesn't flip. They're also not consistent with logical implications of their predictions, such as transitivity. Machine comprehension. Vocab and part of speech tests in Table 3 show that Bert often fails to properly grasp intensity modifiers and comparison superlatives. It also fails on a simple taxonomy tests, such as matching property, size, color, shape to adjectives, distinguishing between animals, vehicles, or jobs, nationalities, or comparisons involving antonyms. So taxonomy is just how things are related to other things. So I would need more examples of this to know specifically what they were talking about. And it looks like BERT also doesn't, intensity modifiers would be like more, less, that sort of thing. And then comparative superlatives would be like good, better, best. The model does not seem capable of handling short instances with temporal concepts such as before, after, last, and first, with simple examples or with simple examples of negation, either in the question or in the context. If you all are familiar with Gary Marcus, who is a machine learning researcher, is he a machine learning? He might be more like a philosophy researcher. Anyway, he's been beating this drum about mass language models not handling, logical understanding for a while, and has written a lot on that if you're interested. It also does not seem to resolve basic co-references and grasp simple subject-object or active-passive distinctions, all of which are crucial to true comprehension. So this is saying that there's a lot that these transformer language models just don't do that you would expect a human to. Finally, the model seems to have certain biases. For example, the simple negation template, P1 is not a profession, P2 is, I'm assuming this is profession, as context, and who is a profession as question. If we set profession to doctor, P1 to male names, and P2 to male names, e.g. John is not a doctor, Mary is, who is a doctor. So this would be question answering rather than duplicate question detection. The model fails, picks the man as the doctor 90% of the time. Hachi-machi. Oh, that's not good. If the situation is reversed, the failure rate is only 3%. The woman is predicted as a doctor. If profession is changed to secretary, it wrongly picks a man only 4% of the time and woman 60% of the time. So secretary is traditionally, stereotypically, a female role, or role that women would have, and doctor is stereotypically a profession that men would have, even though many women are doctors and many doctors are women. Quick question about Duckling. Yeah, so Duckling is a piece of software that extracts particular pieces of information from text, specifically things like dates and times, addresses, URLs, so things that you could, if you needed to, write your own regular expressions to do, but it's finicky, easy to make mistakes, and Duckling just sort of does it for you, and they handle sort of that work in a very centralized place, and it's had a lot of validation done on it. So if you're doing entity extraction of things like time, Duckling's a good way to do it. Addresses, things like that. Because I don't think Spacey does like temporal duration or addresses. Discussion. Oh, now it's time for looking at this table. Did we do table 2 yet? Okay, so for this, they're only doing Bert and Roberta. I don't know of any commercial products that will do duplicate question detection. They might exist, but if there are any, they didn't look at them. And this is just a summary of what we were talking about. So how do I become more optimistic is the same as how do I become less pessimistic. And Roberta got that wrong 100% of the time. And Bert got that wrong, 69, 70% of the time. Modifier changes question intent. So these are not the same. Is Mark Wright a photographer? Is Mark Wright an accredited photographer? And they are marked as the same about 80% of the time by both models. Changing the same name in both question, the models tended to do pretty well on. Changing one name, they were tripped up by more often. And just sort of generating questions using a neural language model, should change the intent, and they were tripped up by that again pretty often. Interestingly here, Bert was wrong 100% of the time, and Roberta was never wrong. So before becoming and after becoming are different. So if what was Danielle Bennett's life before becoming an agent should be different from what was Danielle Bennett's life after becoming an agent. And Roberta was really good at that, and Bert wasn't, interestingly. Yeah, and then this co-reference where there's two names, one more associated with men, one more associated with women, trying to detect that the female name, or the name more often used by women, is more likely to be matched with her than his. Although I will say Lindsay is also a male name, so I don't know that this is perhaps the best example. And I believe it was initially more often used for men and then became more associated with women over time. So maybe not the best example. Also, that's interestingly a fairly common pattern. So if you're training co-reference on names, it is, at least I should say in the English-speaking world, it is good to have a more recent corpus because of this sort of shift in gender associated with the different names. Looks like Spacey doesn't have what Duckling has. Yeah, Duckling just has more functionality for NER, named entity recognition. All right, so lots of failure modes. And let's see, and then machine comprehension, did we read this? We did. Okay, so this is looking only at Bert, and it's looking for question answering, which I believe is one of the things Bert was trained on tuned on in the original paper. And it looks like all around a lot of answers. So co-reference resolution, that he refers to Antonio, and Melissa, she refers to Melissa. Victoria and Alex, the intended reading is that her refers to Victoria rather than Alex, although again, Alex can be used with her. I don't know about these co-reference resolutions. I feel like they could, the name choices are a little bit iffy to me. And also, gender just from names is a pretty fraught thing to begin with. If I were putting together this task, I would say something like, I'm trying to come up with a good example. Melissa and Antonio are friends. Melissa loves her mom, so you have a clear reference there. Is she friends with Antonio? Because then there's a little bit more information so that you've seen the name and the pronoun before. Anyway, just I don't think that this task is particularly well constructed. Put it that way. But here we go. Dealing with typos changes the answer? Very odd. That should not change the answer. And Bert is a character level model. No, Bert uses WordPiece. I had to pull that out of the oatmeal. Interesting. This is an odd perturbation, although it also looks like it was not successful. So here, Jeremy is more optimistic than Taylor, who is more pessimistic. So comparison with these two words that are antonyms. That looks like that had a very, very high failure rate as well. And then this negation, Aaron is an editor, Mark is an actor. Who is not an actor, it should be Aaron, and Mark was selected as the answer, so it looks like this negation is not being used appropriately. Interesting. And this is really good to know about this model, right? Especially if you're picking a model to put into production, or you're working on a model, being able to communicate this information would be really important. Yeah, Faiza, I wanted the chatbot to store user information, so it means lots of names, phone number, addresses, and so on. And I would put that information not in your chatbot, but in a database that's a little bit more secure. Not that Rasa isn't secure, but we're not. It's the Rasa framework is not designed to store user information. Rasa is built on Spatie. You have the option to use Spatie as part of your NLU pipeline, and we love Spatie. Spatie's great. The Explosion folks are awesome. But you do not have to use Spatie if you are using Rasa. We read through there. Discussion. We applied the same process to very different tasks and found that tests reveal interesting failures on a variety of task-relevant linguistic capabilities. While some tests are task-specific, e.g. positive adjectives, the capabilities and test types are general. Many can be applied across tasks, as is, e.g. testing robustness with typos, so you can do that for anything. You can add some typos and see if that changes the robustness. Or with minor variation, changing named entities yields different expectations depending on the task. So for sentiment analysis, probably shouldn't change anything. For question answering, it should, because the entities are different. The small selection of tests illustrates the benefits of systematic testing in addition to standard evaluation. These tasks may be considered solved based on benchmark accuracy results, but the tests highlight various areas of improvement. In particular, failure to demonstrate basic skills that are de facto needs for the task at hand, e.g. basic negation, agent-object distinction, etc. Even though some of these failures have been observed by others, such as typos and sensitivity to name changes, we believe the majority are not known to the community, and that comprehensive and structured testing will lead to avenues of improvement in these and other tasks. So basically they're saying if you're just looking at a single metric across a large body of test data, you might miss some of these areas where models are failing. Using these systematic tasks and setting them up lets you have a clear understanding of where these models are working and where they're not. User evaluation. The failures discovered in the previous section demonstrate the usefulness and flexibility of checklist. In this section, we further verify that checklist leads to insights for both users who already test their models carefully, and for users with little to no experience in a task. My voice is dead. I don't know if you can tell. I'm gonna say we're done with the paper. If you would like to read this section that's like a specific case study on a particular system, I would highly recommend you do it. It might be useful if you are thinking about possibly applying this to your own work. But I think we have the gist, the general information, and there's another paper that I want to read next week. So overall, I think this is a very principled and reasonable way to evaluate these models. I also think that this way of, the sort of table way of presenting these results would be very helpful. The one thing that I might say is if I were going to present these to other people, failure rate is maybe, model results are often presented in accuracy. So I feel like presenting with accuracy might be a little bit more helpful. And particularly if you were, a stakeholder and you were trying to figure out which one of these models is going to be the best choice for you and your particular application, this might be a really, really good way to see where you're likely to run into problems with different models. I like these examples here where you have the expected behavior and then you can see which models really exhibited that expected behavior and in which cases. Yeah, I think there was a reason it was best paper. I think it's a very reasonable, very structured way to do this. My biggest things that I would point out with this paper is it's extremely English focused. So a lot of the tools that they provide and suggestions that they make are not necessarily going to work well on languages like German or Thai. But I think it provides a helpful starting point that you could build off of. And also, I don't know about these, I really don't know about these particular examples with the trying to match gender to given name, especially that a lot of the given names that they used are not unambiguous. I think matching gender to references to people would be easier in a language with richer grammatical gender marker that I think might be more helpful. This is sort of the tasks that they present, this was the one that I'm most like, I don't know that this is actually super like ecologically valid. All right. Aryan says, instead of fallback intent, is there any way to enter the answer of the query and later to build the model from the same to update the chatbot? Yes. So I think what you're asking about, you can do using interactive learning, either in the command line or Rasa X, and I'll paste a link, and you can let me know if that is what you were looking for. So you can, as you're having a conversation, you can correct the fallback intent, detect the correct intent, and then add that to your training data. Also, if you've Googled something recently and the link was broken, hopefully we fixed that. We've done some pretty major changes for... we've done some pretty major changes to our documentation recently, so it looks a little bit different, and also a lot more information on Rasa 2.0, which is you can download and start using now if you're interested. All right, thanks for joining me today. We'll be back tomorrow with our live coding, continuing to work on the dialect assistant. We'll probably spend a little bit more time on tests, and also handle some of those future warnings that we got, so around joblib and updating our pipeline a little bit. And I wouldn't be surprised if the diet pipeline didn't actually do a little bit better. And we may have to deal with TensorFlow text, so we'll see. But as you may know, I develop on Windows, and I've run into some problems in Rasa, and we are now moving to officially supporting Windows. So if you are having Windows-specific problems, do let us know, file an issue on GitHub, and you could also take a look at it. It's open source. You're free to make a pull request, but also just let us know, and it'll be higher priority than it was in the past. All right. Thank you for joining today. My voice is shot. I'm going to go be quiet for a while. I'll see y'all tomorrow morning for live coding. Have a great day, and I will talk to you later. Bye.